You've done all kinds of work with histograms and dot plots. Let's try something different. How about the box plot? The box plot is interesting because it focuses on the median. The median's really useful for skewed data, and so the box plot can be very useful for analyzing skewed data. Take a look at the box plot. We're going to take a look at an example so we can understand what the pieces mean. Then we'll actually try to work with a few. Here we conducted a survey. We asked a bunch of people how many pets they had. We began by looking at that data and finding the median. The median is 2. That median corresponds with the center line in the box. Now let's look at each half of the data. On the left-hand side, we take a look at those values and we find the median. The median is 1. That 1 corresponds with the outside of the box on the box plot. Now let's take a look at the right-hand side. Once again, we'll find the median. The median is 5. The 5 corresponds with the end of the box on the box plot. The only other things that are noteworthy is that 0 is the lowest number, and that's the left-hand side of the line, and 12 is the largest number, and that's over on the right-hand side. Why it's there as a star, well, that's another issue. It deals with it being an outlier, and we'll talk about that later. What's most interesting about this, though, is if you look at the data up top and the number of values inside of them, each one of those pieces has 7.5 numbers. It just so happens that each piece of the box plot, as a result, also has 7.5 of the numbers within them. Therefore, each section of the box plot contains an identical amount of information. More specifically, each piece contains approximately 25% of our data values. If there are some listed on the side as a star, well, that's because that data point is an outlier, and that's how it's denoted. I'll show you how to determine outliers in just a few minutes. Here's an example. If we have 200 students who we survey about the number of pets they have, and we're given this box plot, here's what we can conclude. We know that the box plot has 25% of the students in each of the 8 regions. So we know that each region must have 50 people. 200 divided by 4. That means there's 50 people there, 50 there, 50 in there, and 50 over here. We can use that to answer a series of questions. For instance, how many people have between 0 and 1 pet? If we look at the box plot, we can see that there are 50 people in that area. How many people have between 0 and 2 pets? Well, what do you think? If we take a look at the box plot, we see that 0 to 2 is in these 2 regions. Each of those regions contains 50 people, so there would be 100 people who have between 0 and 2 pets. What percentage of those surveyed have 2 or more pets? Well, where would that be? 2 or more would be in these regions here. Each of those regions contains 50 people, so that's 100 people. But that's not what the question said. The question said, what percentage of the people? Well, 100 out of 200. That's 50%. And we know that 2 regions combined would have 50% of the people. Now, let's construct a box plot. If you know how to find the standard deviation, then you know how to get all of the information from the calculator that you need to construct a box plot. We begin with a set of data, and we enter those values into the calculator. We perform the one variable statistics calculations, and we get this information. The 5 things that I'm interested in are these: the minimum, Q1, which is the first quartile, the median, Q3, which is the third quartile, and the maximum. Here's what we do. We begin with Q1 and Q3. Those are the ends of our box. Notice the left-hand side of the box starts at 74, and the right-hand side of the box ends at 84. Then we look at the median. We draw a dotted line at the median through the middle of the box. The median is 81, and so at 81, I have my dotted line down the middle of the box. Finally, I look at the minimum and the maximum values. The minimum is at 42, the maximum at 89. I draw the left-hand line out to 42 and the right-hand line out to 89. And now I've completed the box plot. So there is one more thing I might think about. We have a couple of points out here that look like they might be outliers. We actually need to deal with those, but we'll deal with those in a moment. For now, I'd like to take a look at exercise 2 so that you can practice what you just learned. In this exercise, we have 32 cars that were pulled over by the highway patrol and issued a fine for speeding. The amount of the fine is shown on the dot plot. Please enter this data into your calculator and perform the one variable statistics analysis. Then, use that information to construct the box plot. Please pause the video and construct the box plot now. We found that Q1, the first quartile, is 53, and Q3, the third quartile, is 60. Those are the ends of our boxes. The median, 55.5, is the dotted line in the middle of the box. Then, our lines went out to the minimum of 45 and the maximum of 98. Once again, we still have the question of, do we have any outliers? Well, let's deal with that situation right now. Let's go back to example 1. Our question had to do really with 42 and 56. And the question is, are these outliers? Well, let me show you how to figure that out. We're concerned with something called interquartile range. Interquartile range is simply the distance between the first and the third quartile, or the length of the box. If I look how long the box is, the box goes from 74 to 84. That's a difference of 10. So the interquartile range is 10. In order to determine if we have an outlier, we take the interquartile range and multiply it by 1.5. 1.5 times 10 is 15. And so 15 is the length I'm going to look at to find possible outliers. I constructed a purple line on each side of the box. That purple line is 15 units long. Anything that goes beyond the end of that purple line is considered an outlier. Notice the 42 and the 56 are beyond that purple line. They are outliers. Here's what we do. The blue line can go no further than the end of the purple line, so we shorten it down. Then, where the outliers are, we put stars. That shows that we had 2 data values there and that they were outliers. How about on the other side? Well, notice that nothing goes past the purple bar over there, and so there's nothing to worry about on the right-hand side. So here's my completed box plot. And we can always make it look nice by putting it on its own number line. Exercise 2 you already completed, but now we'd like to calculate the interquartile range. Please pause the video and calculate the interquartile range. The interquartile range is 7. Now, multiply the interquartile range by 1.5 and determine if you have any outliers. Then, complete your box and whisker plot. Please pause the video now. When we multiply the interquartile range by 1.5, we find that we get a length of 10.5. The purple bars show that length that you can look at to identify any outliers. On the left-hand side, we had no problems to worry about. On the right-hand side, we do have some problems. The line must be shortened down to match the purple one. Then, all of those points above should be changed to a star. There's 1 star for each numerical value that's an outlier. Those come right down and go alongside the line with the box plot. Finally, if you want to be fancy, you can take that box plot, clean it up, and put it on a number line. This is everything you need to know about getting started to work with box and whisker plots.